Hi, scholars. So if you want to follow along with me, I'm going to do some more examples for you to put in your notes, hopefully to explain more how to do some of these problems so that you become more comfortable with trigonometric functions of right triangles. And so this is where I'm getting these problems and graphics from, page 244 to 246 in our journal. Just as a reminder, remember these are what we learned earlier, where we have sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, tangent equals opposite over adjacent. Those three are easily remembered by SOHCAHTOA. Okay, so sine opposite hypotenuse, cosine adjacent hypotenuse, tangent opposite over adjacent. The reciprocals then are called cosecant, secant, and cotangent, respectively. They're exactly upside down of the three basic ones. We will be using these abbreviations, okay, from now on. So take some notes. We're going to move on. So on page 245, you'll see this chart. These are the special triangles that we went over the other day. This is a 30, 60, 90, no matter how it looks. One of the angles is 30, one of the angles is 60, and of course it has to be a right triangle. This one is a 45, 45, 90. That was half of a square of side 1. And so if we label them this way, we can create this chart so that every trigonometric function has a value. Now I want you to realize where these come from. In the smaller triangle on the left, just so you know, whenever you're drawing it, the 1 or the smallest side is always across from the 30, because that's your smallest angle. Smallest side, smallest angle. Okay, because I showed you that it was half of a equilateral triangle with sides of 2, the 2 is always double that. Okay, and then using Pythagorean theorem, that's how we got root 3. So those numbers, whenever you're drawing this triangle, that's where they come from. If we start out with the basics right here of 30 degrees, then for 30 degrees, the sine ratio is opposite over hypotenuse. That's where we get the 1 over the 2. The cosine then is adjacent. Remember, that's part of the side that makes up the angle. That's right here, over hypotenuse. Now, tangent's going to be slightly different because tangent is opposite over adjacent. So for the tangent of 30 degrees, you're going to want to put this in the notes underneath the chart. It's going to equal 1 over the root of 3. You have to remember root of 3 is an irrational number, so we can't leave it in the denominator, which is why we need to rationalize it. We're going to change the way it looks by multiplying by the equivalent of 1. And so when we end up getting the tangent of 30 degrees, it is root 3 on the top with an entire 3, and that's where this comes from. Okay? Hopefully that's good for you. Once we get our basic 3 here, now we can just do this. The reciprocal of 1/2 is 2. The reciprocal of root 3 over 2, we're going to have to do on the side over here too. So if you have root 3 over 2 and you flip it upside down, look, you've got the same situation. Root 3 is irrational. So you're going to multiply it times root 3 over root 3, right? And so you end up getting 2 root 3 over 3, and that's where this comes from. Okay. And then cotangent is going to be adjacent over opposite, which is just going to be root 3 over 1. So if you've got those in the bottom of your notes, here's how they relate. These two are reciprocals, these two are reciprocals, and these two are reciprocals. So all you have to do is memorize this triangle and all the sides, and then you can get any one of these. Any one of these. So I'm going to erase this for now. You can go back and rewrite them if you want, but that's where those numbers come from. So we are now done with 30 degrees. You can do this for each one. These are 30, 60, 90. So again, if I go to the 60-degree angle and I look at the sine, it's going to be the opposite over the hypotenuse. So you see a root 3 over 2. The cosine of 60 will be the adjacent over the hypotenuse. That's where you get the 1/2. But again, if I'm going to look for the tangent of 60, tangent is opposite over adjacent. So the tangent of 60 is root 3 over 1. So that's why there's a root 3, because you don't have to write the over 1. Okay? And then again, to do the reciprocals, sine is a reciprocal of that. That's how that's how we had to rationalize it. The reciprocal of cosine is is 2. So that's what goes there. And then the reciprocal of root 3 is 1 over root 3, but again, we had to rationalize it. So that's why it turns into that. Hopefully you're getting a much better idea now of how to work with the 30, 60, 90. Okay? It's going to work the same way with your 45 degrees, especially as far as the reciprocals, but it's slightly different because the numbers are different, right? So here your numbers are 1, 1, and root 2. So if I want to just look at this, then sine of 45, and you can use either angle for this, is opposite. I'm going to draw it bigger. This is 1, this is 1, this is root 2. So if you want to know what is the opposite over the hypotenuse, hopefully you can see this. It'll be sine of 45 equals 1 over root 2. But just like on those other angles, right, we had to rationalize it. And so that's where this comes from. It's 1 times root 2 over root 2 times root 2. There you go. Now you may notice that cosine is going to be exactly the same, because instead of looking at the opposite, now you're going to look at the adjacent side, which is also 1 over root 2, so that's the same. And tangent's going to be, try to erase this, tangent's going to be opposite over adjacent, 1 over 1, that's how we get that. And then, of course, these are reciprocals. So the reciprocal of 1 is 1, the reciprocal of this is root 2, and the reciprocal of this is root 2. Hopefully you can now see how all of these numbers come from. We're going to be using this chart extensively throughout the chapter. Okay, so that's why we wanted to take a little bit of time to go through this, page 245 on the chart. You really, really want to know this, okay? So take thorough notes. And now what I'm going to do is use this chart, and in the next little video we're going to do problems on 246 that I'd really like you to follow along and put them in your books with me. Okay, great.